Hello, in this video I will show you how to multiply two sums with each other. It will be probably the first proof you have ever seen, maybe not for all of you, but at least for some of you. Let's start. Some consequences of the distributive law. And this is the formula I'm going to prove. Here I'm going to prove that a plus b times c plus d is equal to this expression. And this holds for all real numbers a, b, c, and d. And before I start proving this, I would like to comment. Well, you have probably multiplied sums with each other, and here you see that in the way in which we are multiplying. So what we are doing here, we take first the first element from the first sum and we multiply it with both elements from the second parenthesis. And this gives us AC plus AD. And then we do the same with the second element from the first sum. We multiply it with both elements from the second parenthesis, and this gives us BC and BD. So you see, this is how it works. And now you will see why it works. So just as a little help, I put here the commutative laws and the distributive law, because these laws will be needed for proving this formula. And you see also that I have changed the letters from small letters to capital letters in the formulas for commutative and distributive laws. Well, just because, so you can see that these don't need to be the same numbers as in the formula here. So how am I going to prove this formula? I will start at the left-hand side. This stands for left-hand side. Left-hand side is equal to a plus b times c plus d. And now I will use the distributive law with large A equal to this first sum, large B equal to small c, and large C equal to small d. So what does this law tell me? This tells me that the expression at the left-hand side is equal to large A times large B, which in this case will be small a plus b times c. And then I have to add AC. It is a plus b, and large C is equal to D. You see, so here I applied the distributive law for the first time. And now I want to apply the distributive law one more time, or even two more times. But you know, first I will apply the commutative law for a multiplication here. You know what commutative law tells me, that it does not matter in which order I write my factors. So here I will apply the commutative law for multiplication, and I will do this twice. So first application of this law will tell me that this first one here is the same as C times A plus B. And the second application of this commutative law for multiplication tells me that A plus B times D is equal to D times A plus B. So here I applied the commutative law for multiplication twice. And you see, I'm almost done here, because now I will use the distributive law twice. Distributive law twice. First time for this first expression here. Maybe I will put it in red. So this, according to the distributive law, is equal to CA plus CB. And the second part here, according to the same distributive law, is equal to dA plus dB. And now you see, I see that I'm almost here, I'm almost there where I had to arrive, but well, I see that I will need the commutative laws for both multiplication and addition. Commutative laws again, because here I have in my formula AC and here I have CA, but CA and AC is just the same. Then next in my right hand side is AD, and I see that I have DA here, but you know, both multiplication and addition are commutative, so I am allowed to put this dA as the second element in my sum, and I can also change the place of the factors. So I get AD, then BC here as the third term, and the last one will be BD, well, BD I can just copy as is. And this is exactly my right hand side. So I have shown that my left hand side of the formula is equal to my right hand side, and this can be repeated for all numbers A, B, C and D, because well, I didn't use specific numbers, I just proved this formula generally. Thank you for watching. Bye bye.